My greetings to you, and welcome to the basement of the Bromo Seltzer Arch Tower in downtown Baltimore, Maryland. And what you're looking at is condensate from the steam system being dumped into the storm system of Baltimore City. And this is probably why the inner harbor never freezes. All this warm condensate. But before it is dumped, it goes through this water meter. And this is how, in some instances, the steam utility, which I believe is now called Vicinity, measures in order to provide a bill. And there's the address, 21 South Utah Street. Goes through this surge tank and heads off into the gloom at the other end of the building. Got a lot of stuff going on here. It's chillers and air conditioning system and all that sort of stuff. Right there is where the steam comes in from the street, from the grid, at about 120 psi. And it's going through this pressure reducing system, which is maintained and operated by the utility. And we dropped the pressure. It originally came in at 35, but they abandoned that low pressure line, and then they built this high pressure to low pressure reducing station to give it about 30-35 pounds. And you can hear it hissing away. That's a safety trip lever, so if the pressure gets too high, that will trip and shut the system down. And then this is the actual pressure reducing station right there. You can see the discoloration on from the paint. And these are the various traps, which then send the water down the drain there. That's the cooling leg for the condensate to keep the temperature down below legal limits. All of this here is for the condensate that runs through once it goes through the tower's heating systems, which are basically 44 radiators. These radiators then shed any excess heat before the system is dumped. Alrighty, it's a real mess here. Let me back away slowly. There we go. So up overhead there is the 2-inch supply. That's the first shut-off valve. Okay, sorry about that. Shut-off valve, and then it goes to the building's pressure reducing station. Let me climb up on this ladder here. So there's the incoming pressure at 30 pounds per square inch. There's our emergency bypass, which really probably isn't necessary. There's another shut-off valve. And there's another shot at the main valve. 1 inch, and that is the shut off. That's how the steam is shut off by the thermostat. The thermostat controls this Bromo valve, which then shuts the steam off to the pilot control. Now the pilot control is a little different than what is seen in other systems. This is a D Delta 5, which is with that color spring. You see it's fairly large. Is designed to be able to maintain a pressure of no more than 3 psi. Just really nice. So let's get a shot of the downstream pressure. The gauge on the right is actually reading 0. It's a 0 to 30 psi and a 0 to 30 inches of mercury. The gauge on the left is the actual low pressure gauge, which is the outer dial there is reading in inches of water column. And that's reading at about 30 something inches of water column, which is just a little bit above a pound. And that is the control line, which is back feeding into the brains of the operation here. That's this valve here. So the upshot is by tightening these nuts here, putting pressure on this spring, which is overcoming the pressure from the downstream side. Right there. Let's see if I can focus. Yeah, it's a little tight in here. Sorry about that. And then we'll stroke this valve closed, which will drop the pressure on the diaphragm, and which is fed in here. Pressure is fed in here, which opens and closes this valve, and the excess pressure is bled away through. Ouch! Sucker's hot. That bleeder there. So let's go ahead and tighten these lines, and I think as I tighten these you'll be able to hear the steam pressure, the steam flow increase. You can hear the diaphragm click. It's a stainless steel diaphragm. Yeah, I made one turn. And you can see the pressure is up to, looks like about a pound and a half, or about 40, close to 50 inches of water column. Now it doesn't recover quite as quickly if you drop the pressure. This system is fairly large. The steam is fed up. There we are. Drop that down a little bit. And you'll see the pressure drop slowly. So we want to maintain this at about a pound and a half. Not much more than that. And this is the 4-inch line. A little steam water hammer there. The pipe is off pitch. There's your first drip trap there. We got an inline trap to try to keep this from not being a headbanger. And the condensate line goes back to those radiators that I showed you earlier. We got a trap testing station, so we're able to shut this off, and we're able to blow out the sludge that might be in that Y strainer. And we open this up to see whether any steam is bypassing that trap. That's the main drip trap for the riser. This riser goes all the way up to the 16th floor. That's an expansion loop overhead there in that stairwell, and that's the main drip trap, which carries the steam away. So the steam is going up and the condensate is rolling back down, and that's going back to the radiators and winding up there, which is where we began. So yeah, the pipe that I replaced was 2-inch and hammered like a son of a gun, so I put in 4-inch, which seems to work a little bit better. Let's see if the pressure's dropped. It's dropped a little. Let's see if I can dial this back a little bit more. Yeah, you can really hear it. There we go. And there we're back down to about 30 something, which works up to just a little bit more than a pound. And you can hear the thing quiet down. It's nice and quiet. And so she's a beaut. Now why we were here is we had to replace this. This failed, and so we just simply swapped it out. I tried taking these out on the other one, and one of them just got stuck and wouldn't come apart, and would require a little bit more. So there she is. I thank you for joining me on this adventure. I hope this was interesting. Some of you may know this stuff. Some of you this may be foreign. These are zero clearance unions. You actually can take them apart, and there's no inner part, so this can drop down with you don't have to push it apart for clearance, which is a really nice feature. So I hope I've showed you everything down here. This video is starting to get a bit long. Oh yeah, so anyway, it goes up to the 16th floor. That's right. And it comes down in several drips. This is the end of the steam main, and this is one of the feeds to one of the radiators in the upper lobby there. You want to go in the upper lobby and take a look? Sure you do. Let's go take a look at it. Yeah, this is going to take a long time to... Yeah, that's the unit we pulled out. Up the stairs we go. Put that there for now. All right. Here in the lobby of the Bromo Seltzer Tower. That radiator is getting nice and warm. This is actually the furthest radiator on the system. The steam comes in about underneath that bathroom there, where I showed you earlier, and it rises all the way up in the northeast corner of the building and loops around and comes down there. This is one of the ones. We've got a lot of these TRVs on the system there. That's one with the remote sensor, and just about all of them have these Sarco half-inch Sarco H traps, which require that weird hexagonal head, and they were all rebuilt back in '07. Odd buzzing noise. I think this stays open, that's right. There we go. And this is the only other radiator that's down here. And so the three radiators down here. This is a hand control. That's where that I showed you that trap downstairs was. This is a hand control. Been able to rebuild this valve. And then there's the Sarco trap, and this is the return, which eventually winds up going through those radiators that I showed you down in the basement, and then going through the water meter and then dumped. So let's get you a shot of sort of, there's the steam coming down, the steam coming down and the condensate going down, and this is the condensate coming down from all the radiators that are in the southeast corner of the building. There we are. Bromo Arch Tower. And I think I've got some shots of the clock in earlier videos. If you want to check those out, they're pretty cool. So I think this video has gone on way too long. I hope it's hope it shows you something interesting, and y'all take care.